Welcome to Learning to Engineer. In this video, we will solve some tricky problems in Z parameters. They are not exactly tricky problems, they are actually a little one level above the usual problems because they are going to help you understand the concepts better. Let's get started. To watch a video on the basic concepts of two-port networks and Z parameters, check out this video and then quickly jump back here so that you will be able to try and think about these problems as well. So let's quickly solve the first problem. The question is, a two-port device is defined by the following pair of equations. I1 is equal to 2V1 plus V2 and I2 is equal to V1 plus V2. Find the Z matrix. These are the equations for Y matrix. We all know that Y matrix is the inverse of Z matrix and vice versa. So in this, let us find out the inverse of this and hence find out the Z matrix. The given matrix is 2, 1, 1, 1. The Z matrix will be 1 by the determinant of Y matrix into the adjoint matrix of Y. The adjoint matrix is the transpose of the cofactor matrix. So let us first find out the determinant of this matrix. The determinant of this matrix is equal to 2 into 1 2 minus 1 into 1 1. So the determinant of this matrix is equal to 2 minus 1 1. So what is the transpose of the cofactor matrix? Adjoint matrix will be the cofactor of 2 is 1, the cofactor of 1 is minus 1, the cofactor of this one is minus 1 and the cofactor of this one is 2. The transpose of this will give us the adjoint matrix, which is nothing but 1 minus 1 minus 1 and 2. So let us now find out the inverse of Y matrix, which is the Z matrix. The Z matrix will be 1 by the determinant of Y, which is 1 by 1, into the adjoint matrix 1 minus 1 minus 1 and 2. So the Z matrix is 1 minus 1 minus 1 and 2. This is the Z matrix. Let's now solve another problem. For solving this problem, you need to know some basic idea about Thevenin theorem. We need to find out Thevenin equivalent resistance so that we will be able to solve the next problem. So quickly watch this video where I have explained the basic concepts on Thevenin's theorem as well and then come back to the next question. Sometimes in some question it's not possible for us to apply only one single formula or one single procedure to solve that. So sometimes we need to think about 2 or 3 more methods. So for that we need to know some basic concept as well. So that is why I always insist my students to understand the basic concepts and straight away try to solve the problems themselves, and only then we will be able to understand the concepts better. In case we have misunderstood something while solving problems, these misunderstood concepts will become clear to us. Now let us solve another such problem in Z parameters. This is actually a mix of Thevenin's theorem and Z parameter concepts. The question is, with the 10-volt DC connected at port A in the following linear and non-reciprocal two-port network, the following was observed. 1 ohm connected at port B draws a current of 3 ampere and 2.5 ohm connected at port B, it draws 2 ampere. The question 1 is, with 10 volt DC connected at port A, the current drawn by the 7 ohm connected at port B is dash. The second question in this same scenario is, for the same network with 6 volt connected at port A and 1 ohm connected at port B, draws a current of 7 by 3 ampere. If 8 volt is connected in port A, the open circuit voltage at port B is dash. In the given question, we have two cases. We have two resistance in the output port. In the first case, the resistance is 1 ohm and the current drawn by this is 3 ampere. In the second case, the resistance is 2.5 ohm and the current drawn by it is 2 ampere. So, in both the cases, the input voltage remains the same. When we look at this network from the point of view of the resistor, the Thevenin equivalent voltage is going to remain the same. Why? Because the input voltage is same. As long as the sources are same, the Thevenin equivalent voltage will also be the same. Same for Thevenin equivalent resistance, because when we are trying to find out Thevenin equivalent resistance of one network, we will look at the network from the point of view of the load resistance. So, in both these cases, this 1 ohm or this 2.5 ohm doesn't matter. So, therefore, RTH and VTH are same for both these nodes. Once we are able to find out them, we can find out the current that is passing through the port 2 when we have 7 ohm resistor. V2 will be I2 multiplied by RTH plus RL. If we see, I2 for the first case is 3 ampere and I2 for the second case is 2 ampere. So, let us just substitute in this equation 3 into RTH plus 1 is equal to 2 into RTH plus 2.5. So, when we take this term inside, we will get 3 times RTH plus 3 is equal to 2 times RTH plus 5. So, this implies that 3 minus 1 RTH is equal to 5 minus 3 2 ohm. Let us substitute the value of RTH over here. Let us consider for the first case, because this open circuit voltage depends only on the independent sources present in the network. Since it's 10 volt for all the three conditions, so the open circuit voltage remains the same regardless of the output resistance. Only thing is the value of I2 will vary depending on the value of RL. Okay. So, when we substitute RTH is equal to 2 ohm in this equation, we will get V2 is equal to I2 for the first case is 3 ampere, RTH is 2 plus RL. What is RL? 1 ohm. So, this is equal to 3 into 3, 9 volt. Therefore, the Thevenin equivalent voltage is 9 volt. So, with this information, we can quickly find out the value of I2 when the value of RL is 7 ohm. We will use this equation again. The voltage 9 is equal to I2 dash, because this let us label this as I2 dash into RTH, which is 2 ohm, plus RL. What is RL? 7. So, the value of I2 dash is equal to 9 divided by 9, 1 ampere. So, when we have a resistor of 7 ohm in the output port, the value of I2 dash will be 1 ampere. Using these same cases, we also have another question in this problem. The second part of the question has 6 volt as the input voltage source, and so what will happen? The value of VTH alone will change, because since we are not making any modifications over this network, the value of RTH won't change. Since we are changing the input source, the value of VTH alone will change. We will see that problem. In this network, it's clearly given that this is a linear and non-reciprocal network. So, what can we conclude? Since it's not reciprocal, there should be some dependent sources present here. Okay. So, the Thevenin equivalent voltage will be some constant times the input voltage plus beta. Both of them are constants, because this represents the dependent source and this represents the independent source. Okay. So, what we will do, we will find VTH using the information that is given to us. In the first case, they are connecting 6 volt and 1 ohm resistance will draw 7 by 3 ampere. For the same network, if 8 volt is the input source, therefore, in the modified case, what is V1 dash? V1 dash is equal to 6 volt, and what is RL dash? RL dash is equal to 1 ohm, I2 dash is equal to 7 by 3 ampere. If V1 dash dash is equal to 8 volt, RL remains the same. So since again we are not making any modifications over this network, our TH remains 2 ohm. Only thing is the open circuit voltage VTH will change. We will find that using this information. Okay. So when V1 is 6 volt, RL is 1 ohm. I2 is given as 7 by 3 ampere. So what can we conclude? What is the value of the voltage across this? V2 is equal to minus 7 by 3 volt. Now for this case, let us find out the Thevenin equivalent voltage. Thevenin equivalent voltage when V1 is 6 volt. VTH is equal to V2 into RTH plus RL, right? So this is equal to 7 by 3. Okay, again we are considering the voltage across this resistor, but not the, we are considering the voltage across this resistor, but not the voltage across the two-port network. So we can peacefully ignore this minus sign as well. So V2 is equal to 7 by 3 into RTH is 2, RL is 1. So the Thevenin equivalent voltage is 7 volt. So what we observe, when the input voltage is changed to 6 volt, VTH is equal to 7 volt. In the previous case, what was V1? V1 was 10 volt. What was the VTH? VTH was 9 volt, right? So, in this equation, we have two unknowns, okay, alpha and beta. Using these two information, we can find out alpha and beta, okay. VTH is equal to alpha V1 plus beta. In the first case, 9 is equal to 10 alpha plus beta. 7 is equal to 6 alpha plus beta. Let us solve both these equations now. So if we just subtract, we will get 2 is equal to 4 alpha. So this implies alpha is equal to 0.5. Alpha is equal to 0.5 means we will substitute that in the first equation. 9 is equal to 5 plus beta. So this implies beta is equal to 4. So now what is asked? This voltage is asked. Open circuit voltage is asked. Okay. So VTH is equal to, now V1 is changed to 8 volt. So now we have to substitute V1 as 8 volt and we have to find out the value of VTH. VTH is equal to 0.5 into A plus beta, which is 4. So VTH is equal to 4 plus 4, 8 volt. When VTH is 8 volt, let us substitute VTH here. We will be getting 8 is equal to V2 into RTH is 2 ohm. RTH is 2 ohm, RL is 1 ohm. So what is V2? V2 is equal to 8 by 3 volt. This voltage is 8 by 3 volt. In solving problems like this, we might use a mixture of so many concepts. We need Thevenin's theorem, we need to have a basic idea about dependent and independent sources. So once we mix all these formula, we will get a clear picture of what we are trying to achieve using Z parameters and Thevenin's theorem. Now we will solve another problem. It's a little easier, it won't be this complicated. We will now solve another easier problem. The Z parameters of the two-port network shown in the figure are Z11 is equal to 40 ohm, Z12 is equal to 60 ohm, Z21 is 80 ohm and Z22 is 100 ohm. The average power delivered to the load resistor RL 20 ohm in watt is dash. In this question, we have a two-port network given and there is an internal resistance of 10 ohm connected to the first port. This is the internal resistance of the 20 volt battery. We have a load resistance of 20 ohm they have asked us to find out the average power that's delivered to this load. We have the Z parameters that is given to us. So we can quickly find out the equations V1 and V2 in terms of I1 and I2 and apply Kirchhoff's voltage laws here and here and find this and find out the power. Okay. So the first step to solve this problem is, so first we will find out the Z parameters, find out the Z equations from what is given to us. Then we will equate KVL at loop 1 with the Z equation number 1. Okay. Next what we will do, we can equate the KVL applied at loop 2 and Z equation number 2. So using this we will be able to find out the parameters I1 and I2. With the help of I2 we can find out the average power that is delivered to this load. Okay. So what is the Z equations from this? V1 is equal to 40 I1 plus 60 I2. V2 is equal to 80 I1 plus 100 I2. Okay. So what we will do, we will apply Kirchhoff's voltage law in the first loop. This is loop 1. We will apply Kirchhoff's voltage law there. So if we apply, what we will get? 20 volt is equal to 10 times I1 plus V1. This is 20 volt. Okay. This is V1 plus minus. This is V1. This is V2. Okay. So this equation is 20 volt is equal to 10 into I1 plus V1. Okay. So what is V1 from this? V1 is equal to 20 minus 10 into I1. So let us equate this and this. Okay. If we equate, we will get 40 I1 plus 60 I2 is equal to 20 minus 10 into I1. So we will be getting 20 is equal to 50 I1 plus 60 I2. We will have this aside in the loop 2. If we apply Kirchhoff's voltage law in the loop 2, we will get V2 is equal to ILRL. Okay. So since this V2 talks about the voltage of the output port, this voltage is negative. V2 is equal to minus of, what is RL? 20. Minus of 20 into I2. Okay. So now what we will do, we will equate this and this. Okay. So 80 into I1 plus 100 into I2 will be minus 20 I2. So this implies that 80 I1 is equal to minus 120 into I2. So what is I1 divided by I2? Or I1 is equal to minus 120 by 80 into I2. This will be minus 3 by 2 I2. We will substitute the value of I2 in this equation. Okay. So only then we will substitute the value of I1 in this equation. Only then we will be able to find out the value of I2. So using I2 we can find out the average power that's delivered to the load. Okay. 20 is equal to 50 into 3 by 2 I2 plus 60 into I2, which is equal to, so it is 70, so it is minus 75 plus 60 minus 15 I2. I2 is equal to minus 4 by 3 ampere. So what is asked? The average power that's delivered to the load is asked. What is the average power? I2 square into RL, which is equal to 16 by 9 into 20. This will come approximately equal to 35.5 watt. These concepts for all these three problems, we are just mixing it with some other concept that we already know, and hence we are able to solve this problem. Usually in Z parameters and Y parameters, we have to apply concepts like this. Just by the knowledge of Z parameter will not be sufficient sometimes. We need to know matrices sometimes, we need to know the concepts of Cranmer's rule sometimes, we need to know Thevenin's theorem, we need to know the basic concepts of electrical circuits. Only then we will be able to solve the problems in two-port networks. So for all these, you can check out my channel for all the basic concepts. Once you are able to solve the problems in basic concepts, you will be able to understand two-port networks in a better way. Thanks for watching. Let me know your thoughts in the comment section. If you have any doubts, you can type that down in the comment section also, or you can email to learningtoengineer@gmail.com. Thank you.